All right, so we are still in 14.6 on the topic of triple integration. We're going to do one more problem where all we do is set up the triple integral. In fact, maybe when you take your test, it could have just a problem where all you have to do is set up an order of triple integration. But after we're done with this problem, we will do a problem where we have a triple integral already set up for us, and then we will just begin the process of integration to find the volume. So for this particular one, we wanna set up a triple integral for some solid, and what we know about the solid is it's bounded by z equals 6 minus x squared minus y squared, and it's also bounded by z is equal to 0. So again, as just a default, our order of integration that we're going to assume is going to be dz, dy, dx. And we will change it if we need to do so. So the good news is we do have the bounds for z. So we can go ahead and fill those in if you'd like. So z is bounded from 0 to 6 minus x squared minus y squared. And now, since we're going to move on to dy integration next, let's use the fact that z is equal to 6 minus x squared minus y squared to set up our y bounds. And we do so by, again, just by letting z equal 0. And then, of course, we just got to remember that since we're setting up dy integration, we want to solve for y. So y is going to be equal to plus or minus the square root of 6 minus x squared. And so since we're not told any other restrictions on this solid, we are going to go ahead and write in negative square root of 6 minus x squared and positive square root of 6 minus x squared. So now we have our y bounds. Okay, and then just as in the previous video, let's use this equation of y to determine the constant bounds of x. And so the idea is let's just kind of let's just look at the square root of 6 minus x squared. And let's think about the domain for that radical, right? So as long as we want to stay in the real number system, right? We don't want to travel outside the real number system. Into complex numbers. So given that, let's go ahead and look at the domain. And what we know is that our 6 minus x squared, that radicand, must be greater than or equal to 0. Right? It's okay to take the square root of 0, or anything larger, just not smaller if you want to stay in the real number system. So, in other words, solving for x, we have plus or minus the square root of 6. Or, in other words, x is bounded between negative square root of 6 and positive square root of 6. And there you have it. There's your final bounds for x. Okay. So at this stage, we practiced just setting up a triple integral. What we're going to do is we're going to now take an example where we already have a triple integral set up for us and we just want to practice the integration part of it. Again, after this we'll take a break and we'll come back and we'll do one more video or two more videos potentially, but we have to make these a little bit snappier, a little bit shorter, just because, again, of the time that I'm recording them. In other words, prone to interruptions. Okay. So in terms of, I have spent a lot of time trying to get you to think about the geometry of these regions. Starting with dx, you can think about x being bounded between these two regions. In terms of dy, you can think about y being bounded between these regions. Only when we get to dz, we have to think about our three-dimensional axis. And basically what you have is you have a plane at z equals 0, and you also have a plane slicing through the xy axis at x plus y. So let's go ahead and start this integration process. So we're going to be integrating with respect to z first. And now, if it helps you, you can go ahead and distribute this e to the x so that your terms look like this, if that helps you in the integration process. But we want to begin with dz. So, okay, so if we're going to integrate with respect to z, we're going to treat x and y as if they were constants. So this here is just, we're just simply going to be, these are both constants based on our assumptions. So we're just simply going to be attaching a z to it when we integrate. There is a z in the second term. So you can imagine that when we integrate that, that's going to turn into z squared over 2. So what's going to happen is you're just going to be canceling these 2's. So let me go ahead and set up the result of that. Let me go ahead, if I've integrated, let me get rid of my integral symbol. And so that's going to be e to the x yz plus e to the x z squared. Okay. So at this stage, let's go ahead and, well, first off, let's go ahead and realize that if you plug 0 in for z, that this entire integrand is going to 0 out, right? So really, it's only a matter of plugging in the x plus y. We are going to end up having to FOIL, or we don't have to, but it's just easier in our integration process if we were to FOIL that. But let's not jump ahead. Let me go ahead and at least substitute it first. So this is going to end up being e to the x y times x plus y. And this is going to be plus e to the x, and now x plus y squared. All right. So I'm going to go ahead and carry this over to the next page, and just to kind of tell you what I'm going to do when I get there is I'm just going to FOIL this out. maybe distribute this and see what can be combined. So I'm going to FOIL and combine. Okay, so I'm here. So if you don't mind, let me just assume, let's just assume that I've already FOILed everything out, combined like terms, and at this stage, my integrand looks like this. So, assuming that I haven't made any silly FOIL mistakes, which I've never made a mistake in my entire life, ever, not once. So we can be fairly safe in that assumption. That's a joke. You should have laughed. But let's go ahead and now start our integration with respect to y. So again, if it helps you to distribute that e to the x, not a problem. But I'm going to, at this stage, start to pick up the pace a little bit. So if we were to go through that round of integration, this is what it would look like. So that's going to be 3xy squared over 2. And that's going to be 2y cubed over 3. All right. So again, the good news is the lower bound, if you plug 0 in for y, that would end up zeroing out all the terms. So really it's just a matter of plugging in the top bound. Okay, so we're back substituting for y, so I'll just write it. So that's going to be x squared. I'm going to go ahead and use a different color just so you know that I'm back substituting for y, plus 3x x squared for 2 plus 2x cubed over 3 dx. Okay, so again, let me just kind of pause, make sure that I've transcribed everything. Okay. All right, so at this stage, we can start to distribute all of this, right? So this just becomes x cubed, and this becomes 3x cubed over 2, and this becomes 2x cubed over 3. So what I'm going to do is let me see what I'm going to do. Well, we could try to combine that all into one fraction, if that would help you. But nonetheless, however, as long as you feel okay in the integration process, you can integrate it the way it sits now. You can combine them into one term, one large fraction. But let's go ahead and get to what that result would be. Okay. So let's assume that I combine everything and I bring the constants out in front of the integral. So it should look like the following. All right. So now I have one more round of integration and then one more round of substitution. Okay, you can take a second and see how I went from here to here, but I don't. Again, I wouldn't. It's just a matter of, you can think about factoring out. They all have x cubed. You can think about factoring out an e to the x cubed. Then the only thing that would be left is a bunch of, if you factor out the x cubed from each of these, the only thing you'll be left with is a bunch of fractions to which you can combine. And then you can, you know that we can always bring the constants out in front of the integral. Okay? So one more round of integration now with respect to x. This, we have to make sure we understand that this is a product, right? This last round of integration. Although the last round of integration, the bounds are really easy. The integration part will take a second, right? Because this is, you're integrating with respect to x, and you have x cubed times e to the x. That is a product. So hopefully you still have access to a lot of that knowledge that you learned in Calc 2 on how to integrate products. When you do, it'll be the following. So that's going to be x cubed minus 3x squared plus 6x minus 6. All right. One more round of substitution. And we get, this time we're subbing for for x. The result is the following. Which is roughly 65.797. Okay, this is the volume, and for you engineers out there, this is the volume. Okay, but that's not the volume. This is wrong. It's just, you might be able to accept a little bit of wrongness in your life, but this is the volume. Okay. So we've practiced some basic triple integration. You can see that it's more the same. It's more the same for the types of problems we're doing in double integration. By the way, if you have forgotten this, you'll need how to do integration like this. You'll have to look up integration by parts to refresh your memory. But nonetheless, we'll return and we'll see what else we need to study from this section before we proceed.